Here we go. Hey, hello everyone. This is Sujay. We just we'll be going live in next 2 minutes. Just setting up the stage for you all. Yep, seems to be live. Good. All set, Piyush? Okay. Hey, good afternoon, everyone. This is Sujay. Uh, I'm the organizer for Dr. Penang Meetup Group as well as the Kubernetes Penang Meetup, basically based out of Malaysia. I'm right now located in Penang, is a small state in Malaysia. And along with me, joining today is Piyush Gupta, who is a senior developer advocate from DigitalOcean. And he's basically going to speak about extending Kubernetes and his experience around Kubernetes as a part of the Kubernetes meetup. And I will be speaking about running Docker containers on cloud, basically Azure and AWS, with the help of Docker Desktop. So we'll be dividing these sessions 1 hour each between us, where Piyush first will be taking it over from me and speaking about extending Kubernetes. So handing it over to Piyush now. Maybe Piyush would like to introduce yourself and start the session. Yep. Thank you, Piyush.
Yeah. Thanks, Sujay. Thanks for the introduction and thanks for setting this up. Could you just get the slides up? Yeah, perfect. Okay. It should work, right? So, good afternoon or evening, depending on wherever you're joining it from. And let me just welcome to this meetup. That's a joint meetup with Kubernetes and Docker Penang Group. And I'm Piyush Gupta. I would be talking about extending Kubernetes, right? So, bit of an introduction about me before we go ahead. I work as a senior developer advocate with DigitalOcean. Right? In my previous avatar, I have worked as a developer where I created platform based on cloud native computing and help customers move their legacy applications from legacy infrastructure to cloud based infrastructure, right? I'm an active contributor to the Kubernetes project. You can specifically with the SIG contribex, that's short for contributor experience. You can find me on Kubernetes Slack. My handle there is Spencer91. You can also find me on Twitter with the same handle. And or if you are the kind of person who would rather write down an email, right? So please feel free to reach out to me at pgupta@digitalocean.com, right? So for this stream, we have the live chat, right? So please make use of that. Let me know if you have any questions, and we'll be happy to take that. So this is going to be agenda for today. We will be talking about what's the difference between configuration and extension, right? And since we are talking about extension, we'll see what are the various components that we can use. And then we will discuss the two most used extension components, that is CRD and aggregated API. Right? CRD is custom resource definition, and then we'll see what aggregated APIs are. We'll have a look at uh, what operators are, and then we'll have a short demo to understand how these things work in action, and then we'll just have a look around what service catalog is, right? And if you stay by the end of the presentation, you will have a bonus as well, right? So let's get started. Right. So I assume by now if you are not living under a rock, you are familiar with what Kubernetes is, and what are all the benefits it provides, right? And there are a lot of good things to say about Kubernetes, right? It has got declarative APIs that removes entry barrier from people to move onto the cloud. It has got a great number of primitives, right? You can use a pods, you can use replicas, deployments, daemon set, among other things, right? You get auto scaling, you get auto healing, right? So there are a lot of capabilities that Kubernetes provides, right? But the bigger question is that enough, right? Or is Kubernetes the answer to all your questions or all your infrastructure worries, right? Is Kubernetes a kind of solution that can, one solution fits all kind of a thing, right? There might be scenarios, or there might be cases where it's not enough, right? So what we do in this kind of cases, right? And just let's try to understand why would you want to extend Kubernetes, right? I mean, as a core, or as a tool and as a technology, right? Kubernetes provides you a lot of different things to do, a lot of operations, right? But why would you actually want to extend that? Why would you want to, what could be use cases where you would actually want to extend those capabilities, right? And one of the foremost reason is you want to store additional information, right? So when I say additional information is uh, when you talk about Kubernetes primitives, right? You have got your pods, you have got your replicas, daemon sets, services, deployments, all these things, and all these and all these endpoints, or all these resources, right? They store some information, they store some objects, right? Like if you look at a node object, right? It stores a lot of information about that node, that how what is the disk pressure on that node, what is the container runtime, how many containers are actually running on that node, right? uh, what is the version of that container runtime, all those things, right? These are being stored in that particular object. But what if you have got a resource and you want to store additional information, right? So one of the ways that usually people do that is using labels, right? So you can attach labels to those objects, and that gives you a way to store some extra information. But is that always enough, right? Or would you want to do something more with that, right? If you want to store some more information, right, that label can't suffice you. In that case, you actually go ahead and extend Kubernetes, the core Kubernetes cluster, right? uh, and then Kubernetes has a concept of controllers, right? Controllers are the components that make sure that everything is in sync, and that make sure that the state that you actually require, the state that you have actually requested, is maintained, right? uh, Now, and Kubernetes controllers, right, do a lot of work, right? If you say that, okay, I want three replicas of this particular application, controller makes sure that you will get three replicas. If you tell that I want this many volumes attached to this pod, right, controller makes sure that that happens, right? But what if you want to do something different? What if your use case is to run your own controller that does your own thing, right? Your application might require a controller that you know, just replies to emails, right? Whenever a new mail comes in, or you probably want to write a custom controller for a Slack bot, right? Whenever a notification comes on Slack, you just want to respond back to that, right? So that could be one of the use cases where you would want to extend Kubernetes, right? And one of the most popular one is you have got your legacy applications, you have got your legacy systems, right? Legacy infrastructure. And now when you move on to Kubernetes, you have got two options, right? Either you rewrite everything from scratch, right? You probably redesigning everything, make it microservices based, and then make sure that Kubernetes supports that, and all the primitives fit in. Or what you can do is you can just extend Kubernetes, and you want to make use of Kubernetes capabilities as well, right? So what you do is you basically uh, write down your own controllers, write down your own services, write down your own resources, and manage those legacy systems using Kubernetes, right? So this way, basically, you get both of best of both worlds. You don't have to redesign everything, though you should, right? But let's say you don't want to do it as an immediate thing, right? Right now, that's not a priority, right? To re-architecture everything, but you still want to make use of Kubernetes functionalities or Kubernetes, the capabilities, right? So what you do is you just extend Kubernetes, you write down your own controllers, among other things, and then you can manage those legacy systems, right? And of course, you don't want to change core Kubernetes code, right? Kubernetes is huge, right? Uh, like any other distributed system, it's complicated, right? And changing core is even more complicated than that, right? So you have got a cluster setup, you have got a cluster running, but let's say you want to change something in that, right? You will have to probably do a regeneration of code, make a lot of things, change a lot of things, make sure the dependencies are met properly, and then you don't know where it will break because Kubernetes, when Kubernetes team releases a new a version, right, it is tested extensively. If you change the core, you don't know what will break at what point, right? So you don't want to change the core functionality, but you would still want to add something to it, right? The best way is to go with extending the Kubernetes, right? Now let's talk a little about multiple ways you can do that, right? And as we saw in the agenda, one of the things that we will discuss is about how you can differentiate configuration and extension, right? So Kubernetes engine, I mean, originally was designed to be, extensible and configurable, right? There are a lot of things that you can do, and all the core components, right? Be it kubelet, be it API server, be it controller manager, be it your schedule, right? All these things uh, can be all these capabilities can be improved via flags, right? So they support multiple flags, right? Let's say if you are using kubelet has a CNI flag as well, right? So if you want to use a different kind of network, you can just tell kubelet, okay, don't use this particular network, I want to use this particular network, right? um, with API server, right? If you want to use some different kind of new alpha feature, right? So alpha feature are not enabled by default, right? So if you want to enable something like that, right, you can just provide a specific flag, right? And you can make use of those facilities, right, or those capabilities, right? But these things, I mean, though these things provide a certain level of extensibility, but this is not an extension in a purest form, right? This is just configuration change, right? And one of the thing is not everybody can do that, right? I mean, if you are running a production level cluster, you wouldn't give everybody access to go and change control level parameters, right? That simply doesn't make sense, right? That would be a big security loophole. And these things are usually done by cluster administrator, right? In other case, if you are using, and that is still feasible to do if you are running your own Kubernetes flavor, something like a Minikube or a KubeADM kind of a thing. But if you are using a managed cloud provider, right, something like Google, Amazon, or DigitalOcean, right, it becomes almost impossible to do that because they have their certain set of rules that they only allow. So changing those, basically you don't get access to the cluster administration, right? So you won't be able to change anything like that, right? These things might change in future releases because there are stable features, right? There are a lot of things in Kubernetes moving from alpha to beta to stable, and then getting deprecated among other things, right? So code cleanup keeps happening. If there is some legacy support that's been going on for quite some time, doesn't mean that it will be there in the next release as well, right? So these things might change, and you will have to keep track of these things, right? If this doesn't work out, right? And a lot of time this also requires restart of services. Now when you restart, right, the service is gonna be down for a certain amount of time, and then that is obviously not desirable, right? You wouldn't want just to enable some flag. You don't want your cluster to be down or your services to be down for any certain point of time, right? So you would actually expect that you know you would actually expect that you can run your services without worrying about the cluster downtime, right? You would want a mechanism where you can do this dynamically, right? Right. So let's look at in contrast what exactly is extension, right? It's not just changing configuration, right? And when you say extension, it basically means software components that are going to run independently and they are going to integrate with Kubernetes, right? That's the whole idea behind talking about integration, right? Behind talking about extension, right? It's not just about that you enable something and that is still a part of Kubernetes, and then when you enable a flag, it will load some code, and then you would be able to do stuff because that is predefined. Extension is actually running something independently, something separately, and then integrate it with the core Kubernetes, right? So you can still make use of all the benefits that Kubernetes provides, but how it reacts is completely in your control, right? So if you look at the second line, the idea is to support new types and take actions on them accordingly, right? So let me just give you an example. You have got pods, right? And when you create a pod via ML and you send that request to Kubernetes API server, API server looks at it and it understands, okay, I'm supposed to create a pod, right? And the controller takes care of maintaining the state, and the instruction goes to kubelet, and kubelet starts container, and right, that's how that action happens, right? But extension provides you to define your own type, something like a pod, something like a replica set, something like a deployment, right? And you can also make sure that once you send those instructions to API server, there's a controller running who takes care of taking action on that, right? And you can still talk to it like you would talk about a pod, right? Like we would do a kubectl get pod, and then we will see that in demo how actually it works, right? So I'm just going to take a minute to talk about this slide, right? And this basically shows how extensible Kubernetes is, right? It's not just about just don't take my word for it. Right? So let me see. Okay, right. So this basically talks about the Kubernetes architecture, right? And if you see at the top, that basically describes how you would talk to a Kubernetes cluster, right? You want to talk via kubectl, or you have got an API written in client code, right? Or something else, right? It could be anything, right? Now by default, most of the time people use kubectl, and kubectl is very extensible, right? You can basically use your plugins, right? You can add plugins to it. There's a config file. You can add plugins to those, and you can use it with them, right? One of the thing is this would be a client side changes, right? So it doesn't have to reflect on the API server side, or the control plane side, right? So whatever plugin you do, you use whatever computation that plugin is going to do, or whatever visualization the plugin is going to do, it would be all in the client side, right? So it's not going to be on the server side. And then the second part is Kube API server, right? So Kubernetes API server is really the heart of all cluster, right? Every component talks to the API server, and then API server, whatever processes it implies, right? It does that, and then controller take action based on that, right? But you can also extend the API server, right? You can also run your API server side by side, right? And if you think about it, how cool that would be, right? You have got one API server, and that's something that we will talk about as a part of aggregated API. But the idea is that you can start running, uh, you can run your own run your own API server, and the actual API server is going to proxy all those requests that are coming to that particular endpoint to your API server, and then you can take actions based on that, right? And then if you move down on the third point, Kubernetes has got primitive resources, as we were discussing. We have got pods, nodes, replica sets, etc., etc., right? Uh, can you extend those, right? And that's exactly what CRDs does, right? So if when you talk about custom resource definitions, right? So what they usually do is you can extend resources, right? You can extend those endpoints. You can create your own endpoints. You can create your own resources, and then Kubernetes API server will basically treats them as the resources at another endpoint, right? And you can talk to them like you're talking about Kubernetes primitives, right? And then you have got the fourth point, a scheduler, right? So Kubernetes has a scheduler, and it does calculate where your pod should go and which node should be available, and set up the priority list among other things, right? Set up some predicates, etc. But if you want to do scheduling based on some of your own logic, right? You want to set up a pod just going, you want to prioritize the nodes basically based on some of your requirements, right? And some of your custom requirements. You can do that. You can run actually another scheduler with that. You can also have a custom controller, right? So when we talk about if you look at the point 2 and 3, right? When we talk about extending the API server and extending the resources, right? You also extend the controller, right? So controller is the one who will actually be taking actions, right? We will be actually making sure that the state that you desire is actually maintained, right, across the cluster. And so you can run your own controller, and then when you mix all of these things, you actually get a true extensible platform, right? And then on the sixth point, you have got network, right? So if you have been using Kubernetes, you would know that Kubernetes has a concept called CNI, that's cluster network interface, right? And you can use the network interface to write your own network plugins, right? Depending on whatever network plugin you want to use um, Calico, you want to use VNet, you want to write down your own plugin, right? You can do that. So network is pretty extensible. And if you look at the storage, it's the same story as network, right? So you have got container network interface, you have got your container storage interface, right? So CSI does the same thing. CSI allows storage vendors to write their own plugins, right? And you can integrate it with Kubernetes cluster, right? And that's interesting because if you look at the storage part, right, there are so many storage vendors, right? And if Kubernetes starts putting all the storage vendors code in their you know in their core Kubernetes code, right, it's not going to work for them. I mean, the code base would be too large, right? So you need extensibility in that feature, right? Now, if you look at it, right, we discussed what 7 points, right? So if you include that 7 points, right, these are the main cluster components, right, and each of them is extensible, right? So that basically shows, right, how extensible or how modular the design of Kubernetes is. Right? Moving on, right. So the two things that we would discuss mainly here is extension with custom resources. That's the third point, and then aggregated API, right? That would be the second and fifth point, right? So let's look at custom resources, right? So in Kubernetes, right, every resource is basically is an endpoint. It's going to store a collection of objects, right? So just to simplify that, when you say a pod resource, right? So pod resource is going to store pod objects, right? That's what the whole purpose of using a pod resource is, right? And when you say pod object can create or basically can have multiple parameters, right? It mandatorily has to have container name and an image, right? Now you can also and when you give those parameters, the resource knows, okay, there is a new object that has been created, and then the controller that is actually managing pod, it knows that, okay, there is a new resource that has been created, and now I should make sure that the state is maintained, is talk to API server, and the API server talks to etcd, and they make sure that a new pod is created, right? So their state is consistent, right? Now, custom resource is basically, now the idea is you can create your own pod-like resource, right? That's what a custom resource is. It's an extension of Kubernetes API that is not available by default in a standard installation, right? Uh, Now, when you say standard installation, again, that can have different meanings. You get different type of installation with Kubernetes. But yeah, I would rather say it, that are not Kubernetes primitives, right? And when I say primitives, I only take, the basic stuff like pods, replicas, and deployment, etc., etc., right? Uh, Even if you have CNI plugins, right? If you run a Kubernetes cluster, you need CNI plugin. All of these, they are implemented as custom resources, right? And that is one of the good things, right? As this is one of the things that we discussed. You wouldn't want to change the Kubernetes core, right? You wouldn't want that, okay, you change something and then you will have to recompile it and rerun it, right? That just defeats the whole purpose. So, custom resources can be added or removed via dynamic registrations, right? You're basically you don't see any downtime on the services. You don't see any downtime with the cluster. You just tell, okay, this is my custom resource, and you register it with the API server. That's all. And you can access it using kubectl. There is That's like, one of the high priority thing, because you want to make use of Kubernetes capabilities, right? You just don't want to create a resource, and you can couple it with a custom controller to provide a true declarative API, right? So when we talk about declarative API, right, when it basically means uh, you you apply a state, and the controller makes sure that the state is maintained, right? Whatever state you have been desiring. And if you add the custom resource with the controller, right, that's what your declarative API is, right? Whenever you create a resource, the controller will be watching, that okay, whatever is happening on this, whatever is happening on the resource, and whenever you add a resource, it will just create a new, probably a new pod for you, or create a new event for you, right? And whenever you delete a particular resource, it will just take the opposite action of that, right? And that's for something that you can control, right? So this is like, you just focus on the logic, what you want a controller to do, let Kubernetes handle everything else, right? So that's what about custom resources, right? Let's take a look at what aggregated API is, right? And aggregated API is an aggregation layer that would run in process with API server, right? So you have got an API server, right? And whenever a request goes to API server, right, there are few steps that it has to cross whenever an action goes there, right? You have to do the authentication, you have to do authorization, and then you have to do admission, right? Now, if you take these three steps, right, uh, there is also now you want to implement your own stuff for that, right? Kubernetes has got something, but you want to add something to that, right? Or you want to do all these things by yourself, right? You want to implement your own mechanism to do all these things, right? That's where the aggregated API or aggregation layer comes in. The idea is you run another API server as a pod in that cluster, right? You want to do your own authentication mechanism, or you want to do your own authorization mechanism. You don't want to use RBAC, right? You want to do something else, right? For your own resources, right? You What you do is you put that code inside a Docker image, or anything else that you are using, whatever container type you want to use, and you run it as an extension, right, inside a pod. Right. And then you have to register that API with the API service object, right? So basically, whatever path you want to choose, right? There are multiple API endpoints, slash pods and slash stores, that kind of a thing. You can register it with your API server, and as soon as you register that, right, whenever a request that is going to come to for that particular endpoint, it would be proxied back to your API server, right? So think of it this way: you have got the main API server running, and behind that there is your own custom API server running, right? And it will listen to, let's say, an endpoint called slash custom API, right? So whenever there's a request that is coming for forward slash custom API, your main API server is going to proxy that request back to your custom API server. Then your custom API server can take any action that you want to take on that, right? Usually, I mean, just so that your cluster remains sane, there is a restriction of 5 seconds uh, when when the request goes from your API server to the custom API server and it comes back, right? But again, it's not a hard coded thing, right? We By now we know that Kubernetes is highly configurable and extensible, so this doesn't have to be a high limit, right? Uh, you can configure that there's a flag or an environment variable that you can measure, but this gives you a good, good standard, right? Okay, usually things should happen in that much time, right? Now, what exactly is an operator, right? So now, if you we discussed about net custom resources, and we also discussed about an API, aggregated API, right? But there is also one point. If you look at the slide, right, there is also the point number 5. There's a controller, right? So if you look at controller, so, if you merge both of these things, you have a custom resource that is going to store information, and then you will have a controller that is going to take action based on that resource, right? You get an operator, right? So that's the idea behind operator, right? So if you look at it, it basically automates forms of human operator, right? So imagine that there's a Kubernetes cluster operator, right? Uh, what his job would be, right? And the job would be to basically watch a declarative API coming in, new resource being created, and then take action based on whoever is creating those resources, right? If you want to, if the directions are that okay, if the resource come in, create a service, right? You would do that. If the directions are when the resource is created, you have to create a deployment cycle, right, or something like that, right? Now, what if you can automate all that process so that you don't have to do all of this manually, and that's where operators come into the picture, right? You automate that whole cycle, starting from creating a resource, reading it up, and then taking action on that, following the deployment cycle, probably deleting that if required, among other things, right? So, right, let me. Okay, perfect. Right. So let's look at demo how it actually looks in action. Right. I'm gonna give me a minute. Okay, perfect. I'm just gonna increase the font size. Okay, I hope that's visible.
Yes, that's perfect, Piyush.
Sure. Right. Right. So yeah, let's first look at CRDs, right? What CRDs are, and how you can implement them in a cluster, right? So what basically you need as a prerequisite is of course a Kubernetes cluster, right? So let me just got a Kubernetes cluster here, and there's a DigitalOcean managed Kubernetes cluster, and the version is 1.18, right? Now, let's see. Okay, and I'm gonna just talk through this YML, right? So everything in Kubernetes, works via YML. So I'm just gonna talk through this, how it works and what are the components, etc. Yeah, right. So first thing first is define the API version, like everything good in Kubernetes, right? You just put whatever the API version is, right? So if you are using, I guess, from since Kubernetes 1.16 or something, right? They have graduated this API, right? But if you are using an older version, just make sure that you are using the right APIs, right? So the version we will be using is API extension.krs.io/v1. We want to create a CRD, so we'll just put it as a custom resource definition, right? We just put a name, image stores.example.com, right? And this is where the interesting thing starts, right? When you start writing spec, right? You want to define, you want to see if your CRD would be cluster wide, or you want to limit it to a particular namespace. You can define it here, right? The next section is putting up names, right? How your name is going to look like. So if you see, you can do kubectl get pod, you can also do kubectl get pods, right? Or if you look at daemon set, you can do kubectl get daemon set, or you can get kubectl get ds, right? So all of that configuration is defined here, right? For our CRD or for our custom resource, what we are going to do is the singular would be image store, plural would be image stores, the kind would be image store, and the short name would be if, right? So basically, what I'm trying to do with this CRD is, apologies, right? I should have started with that. The idea is what we want to create. We want to create a custom resource, and it will store image name and which registry that image exists in, right? That's it. Now, you could have a different use case, right? You probably want to store this information so you know where our images are coming from. You want to store certificate information that okay, this certificate is going to come from here, or probably you are a supply chain guy, you just want to make sure that this is the vendor you are getting your material from, right? And that's one of the use cases for using custom resources, right? So coming back to our example, right? So our example is an image store. What it's going to do, it's going to store image name, and it's going to store which registry that image exists in, right? uh, right. So the singular one is called image store, the plural one would be called image stores, right? The kind is image store, short name is if, right? And then we define the group. The group is example.com. You can put it with anything. Uh, groups are basically, they define how your which group your API is actually going to be belonging to, right? So if you see here, if you have created pods, and if you have created daemon set, or service discovery kind of thing, pod just go with v1, right? If you will create let's say daemon set, goes apps /v1, right? Or sometimes it goes like, or if you see here as well, that's the API extension.krs.io, right? So that's the group, and this actually tells Kubernetes API server that okay, this is the group there that this particular resource is going to be belonging to. So for our case, this is example.com, right? And then you define version, right? So again, app/v1 or this/v1, right? So this is our first deployment. We are just going to put as v1. Uh, if you wish, you can also call it an alpha version, right? V1 alpha 1 or something like that, and then you can graduate it to beta and do several other things there, right? And then this is the version that is being served, right? So you can have multiple versions, and you can just put one version served as true, and that will make sure that which version is being solved, right? Then put storage to it. We will require a storage for this, and then you define the schema here, right? And this schema basically takes care of uh, how your custom resource is going to look like, right? What all information are would be the required part, right? Not the optional part, right? So for and this is just a syntax, right? I'm just not gonna go into detail of this, but I'm just gonna point it out that you have two two required parameters here, right? One is the image and one is the registry, right? And that's what we want to do with this image storage, right? You want to make sure that um, you want to make sure that we store an image and we store which registry it belongs to, right? So let's deploy this. ctl apply image store.yml, right? So now it will create the custom resource definition form, right? imagestore.example.com, right? And let's just see if it actually did that. Right. So now you can see here there are a lot of other CRDs as well, right? So uh, DigitalOcean managed Kubernetes cluster have Cilium pre-installed as a networking component, right? So and all that Cilium stuff is stored as CRD, right? Your etcd, that's one of the core component of Kubernetes, work as a CRD, right? And then this is our custom CRD that we just added. Then you have got your NFS servers and storage OS, and then volume snapshot, etc., etc. Right. Now let's take a look in more detail. Uh, right. So if you look at it, we will find a lot of information about it, right? What we are interested in is, sorry, right. What we are interested in API version and the kind of that we are looking at, and then right. So this is the API endpoint, right? Custom resource definition slash image store.example.com, right? And the kind is gonna be image store, and the two things that we require for it to work. Uh, right, image and registry, right? So these are the two things that would be required here, right? Now, what we're going to do is, so since now this is a CRD, right? So this basically tells API server that you can expect a resource that the kind of that would be image store, and it's going to store this information, right? So now what we'll do is let's create a what do you call it? Uh, Object of that resource, right? So what I'm going to do is right. So this is my YML that will actually create an object of type image store, right? So if you compare it with when you create pods or when you create deployments or daemon set or these things, right? You'll be able to see that API version comes as the group slash version, right? And then you define whatever the kind you want to use. Let's say image store, right? This is what I defined in my CRD, and then you define the spec, right? So I'm just gonna put my image is test image and my registry is docker.io, right? And the name of the resource is going to be my image, right? So once I push this or once I apply this, API server is going to know that okay, this is a this kind of resource, right? And I should just store it. So let's say kubectl apply f as object.yml, right? Perfect. And it says this thing is created, right? Let's say how it looks. So, like we just created this particular object, right? Now, if you remember, we had couple of other things as well, right? It was we gave it different name, right? We gave it image store. We got image stores, right? So let's see if image stores work. Perfect. And we also had is, right? So this is the short name. Brilliant, right? Now, I'm gonna do is I'm going to describe it, right? And I can just say describe is, right? I found my image. Now, right here, It's gonna give you a description of what the resource is. It's gonna tell you some certain annotations. This is the API version, right? So if you look at uh, when we described our CRD, right? The API version was the kts.extension.kts.io, right? But here it's example.com/v1 because now API server understands this, right? And this is the kind of resource that we have. These are some generic information, and these are the spec, right? Spec is just the image is just image, and then registry is docker.io, right? So that's so now. No, the idea is you can still use Kubernetes primitives. I still use kubectl get. I still use kubectl describe, and this I didn't have to implement any of these things, right? So basically, what you can do is you can create stuff uh, that is specific to you, or that is a custom to you, and but you can still use Kubernetes primitives. So basically you get both of best of both worlds, right? You use your own resources, but you still get to leverage Kubernetes' multiple capabilities, right? But it's not complete, right? I mean, you are doing this just stores information, right? Whatever data you give it to that resource, it stored it, right? But what if you want to take in some action on it? What if you want to do something different with it, right? And that's where give me a minute. Let me get back my slides. I'm just trying to figure out where did these go. Okay, perfect, right. So what next, right? And that's what an operator does, right? When you create a resource, right, you would want to take some action on top of that resource. It's not like that you created it and it's done, right? When you create an image store, let's say you want to take an action that okay, when I create a resource, you just pull that image on all the nodes, right, or something like that. Could be anything. Now, creating a controller is a bit daunting task than just creating a resource, right? Creating a resource just take 2 YMLs, right? But creating a controller, you need to make sure that it talks to the API server and it has all the right permissions to take actions, and it can actually sync the state that you desire to it, right? And to make that task easier, for you, right? There are a lot of tools that you can use, right? One of the most popular tool is called Operator SDK, right? It has come from Operator Framework project, right? It's part of CNCF, right? And what it does is it gives you a skeleton of sorts, right, that you can use to create an operator, right? And all these things that I just said, right? If you want to create a controller, you need to set up RBACs, and you need to set up, storage options. You need to set up proper permissions. You need to set up the communication channels and everything, right? And all these things are repetitive, right? For any operator you create, whatever you want to do with your setup, you would have to do that. But these automation tools, they take that repetitive efforts away, right? So that you can just focus on your logic, right? If you see on the slides, right, Operator SDK is a framework, and it uses the controller runtime library, and it makes writing operators easy, right? It gives you high level APIs and abstractions, right? So there are a lot of things that Operator SDK will do for you so that you just write operational logic, right? It uses scaffold, and that what scaffold basically does is it creates the directories for you, right? So whatever directories and files for you, so whatever you would require to actually create a good operator, right? And we will just see in a moment that how fast actually it is to create that operator. And then it also has some of the extensions that you can use, and make it, again, make it more pluggable system, right? It can be installed pretty simply if you are using macOS. You can just do a blue install operator CDK SDK. That's how I installed it. But if you are using any other system, the instructions are pretty straightforward, right? You can just run an operator SDK init command, and it would initiate an operator for you, right? It can initiate a project, and it would have all the relevant files and relevant stuff in there, right? And it also it has got support for Go, and Ansible, and Helm, right? So you don't you don't have to know just Go to do this, right? If you are comfortable with Ansible or if you are comfortable with Helm, you can also use that with Operator SDK, right? And as I said, right, Operator SDK is not the only option. You can use Kudo, you can use Cube Builder, you can also use Meta Controller, right? And Meta Controller is one of the projects that I actually also very liked. I mean, it is pretty straightforward to use, and you can create all sort of controllers with that, right? So what we're going to do is right now is let's take a look at okay, let's take a look at how Operator SDK looks and how it can help you. So I'm just gonna. That's why I've installed Operator SDK on my system, right? And if you see here, it can do a lot of things for you. You want to build something, you want to clean up, you want to create a Kubernetes API, right? And in it is basically is what of more interest to us, right? What we're going to do is we are going to let me create a directory for test operator. Right, so we're going to call it test operator. Just create a directory and run an operator SDK init command, right? So now there are a couple of parameters that you need to provide here. You need to provide the domain for which your CRD will belong to. You need to provide the license. I mean, that's again optional. You want to provide owner. I've just put it to Kubernetes Penang, and then you have to provide a repo, right? So if you are running it inside a Go path, then you don't need to provide a repo. But if you're not, you can just provide anything as an example, right? And then you do and enter, right? So it will do some scaffolding for you. It will create multiple directories. It will create you know uh, it will even create a binary for you, right, that you can run, right? And it will even you know it will even tell you what to do next, right? So the next step is to create an API, right? So let's do this. Let's create an API. Right. An API will have which group your resource will belong to, what is the version, and what will be the kind, right? So if you remember for our image store, we had the kind IS. For this, we are going to have a kind Penang, right? Or something like that. And then it will ask you, okay, you want to create resource, you want to create controller, right? And then it will just change those relevant files, and then we'll do a build again, right? So right. Now, if you think of it from an offset point of view, right, creating a resource and then creating a controller to control that resource is going to be a complicated task. But if you use tools like Operator SDK or Meta Controller or Cube Builder kind of thing, right, they make it pretty easy, right? So let's take a look at what all it creates, right? So you will see a lot of things that have been created here. Now it even creates you a Docker file, right? So if you remember, we said that whenever you are running something, be it an extension of Kubernetes, it has to run as a pod, right? Uh, so what Docker file does is it will just take up everything, right? It will take this whole code, right? It will use Golang 1.30 as a builder, and it will take up the API and controllers and everything, right? And this is going to build a binary called manager, right? And this manager binary would be run as part of this. And this manager binary is basically it basically is going to watch your resource and it take action accordingly, whatever action you provide or whatever data you provide to it, right? Let's see where you can put that, right? Another thing is main.go, right? So this is just a function. So this is the main function that is going to uh, run your manager, right? So you just create a new manager and just wait for this, right? Now your logic to run this comes from comes from here, right? So this is one of the main functions, right? I'm not going to go into much detail of how you do that, right? But reconcile is the main function that's going to take care of, and you can define your struct and everything, right? Like we defined for image store, right? We defined image going to be string and registry is going to be string, right? So you can define uh, your structure here as well, right? But what you do with that structure, what you do with that resource, right? That is going to be taken care in the reconcile function, right? So you go to reconcile and you make sure that whatever you want to do, with your resource, you can do it here. And this is going to be watching your resource, right? So whenever you create a, let's say, a new image resource object, it's going to take care of uh, creating a new, probably creating a new pod, or probably pulling that image on your nodes, or whatever else you would want to do. Like, and you can just return result of this and error, whatever. Right? I mean, if it's successful, it's successful. If it fails, it fails. Right? And you can take actions accordingly. Perfect. Right? So that's a bit of introduction about Operator SDK, right? I would, if you're interested in doing that, please do check out. They have a pretty nice documentation, and you can just follow this and create an operator for you. We do have other extensions. For as we talked about network plugins already, you have got CNI, you have got kubenet. For storage, we had Flex volume drivers, or Flex volume drivers are getting deprecated in favor of CSI. So you can create CSIs, and you want to create device plugin. Let's say your system has got NVIDIA GPUs. You want to make use of that. You have got drivers to take advantage of that as well. Right. And this is the last thing that I want to talk about, right? And this is just extension of what we have been discussing till now. Uh, so now let's say your cluster is there, and you have been able to write stuff on your own. You have been able to extend the cluster. You have been able to make use of the extensibility of Kubernetes, right? But that's not always the case, right? It's not like that you would always want to use your own. Uh, you would always want to use your own custom controllers, right? You would always want to write your own stuff, right? There might be cases where there are a lot of managed service providers, right? And these managed service providers are going to give you, uh, you know, they're going to give you, a managed service, and you want to integrate it with your cluster, right? So how do you do that, right? And that's where service catalog or service broker comes into the picture, right? So if you look at the diagram, the dotted diagram, right? That's your dotted area is your Kubernetes cluster, and if you look at the right side of the diagram, you see there are managed services, right? And there's an agent that's called a service broker. That's what it does is basically it excuse me. What it basically does is it sets up a channel between your cluster and the managed service provider, right? And if you see here, there is a lot of back and forth where you can use. You can basically register. A managed service provider can register their services with the cluster, and an application uh, that has access to those resources can use them, right? So yeah, the slide now. What is the fun thing that you can do, right? So and then I came across this morning itself, right? Now think of it. You have the resources and you have the controller that can actually take action on those resources, right? What if, no, sorry, what if you can actually create a controller that can order a pizza for you from Domino's? Or what if you can create a controller, or you can run a cron job, and it's gonna, uh, and integrate with your Raspberry Pi and just give it action to brew you coffee at 6 a.m. in the morning, right? Now, both of these use cases have been tried out in the actual world, right? I'm not just saying them that you can do these things, but these things have been done, right? So these are the kind of things that extending Kubernetes can provide you, right? And of course, these were the fun activities, right? But there have been people who are using it for serious issues as well to manage their legacy applications. As I said, right, that's one of the basic requirements, right? So that's all I had. Thank you for being an amazing audience. Right, I really loved doing this session. And if you want to know more, if you want to, have anything that you want to ask me, you can reach out to me on LinkedIn. You can reach out to me on Twitter, and you can shoot me an email as well. Right, and now it's time for the bonus. Right. So, if you want to try all of these things out, please feel free to go to this link. That's called do.co/Piyush. That's a P with a capital. And you get free $100 credits. You can try it out. You can use our managed Kubernetes service. You can try running your CRDs. You can try running custom controllers, right? And you let us know what the feedback is. Thank you. If there are any
Hey,
question, I would love to answer. Yeah.
thanks, Piyush. Great session, man.
Thank you. Thanks for adding it up.
I don't see any questions in the channel right now, but I do
All
have
right.
one question.
Yeah.
So what I saw is that you were extending using YAML and basically went into using a SDK which used Go language. So is
Yeah.
there an option to use any other programming language other than Go?
Yeah. So, I mean, there is no restriction from Kubernetes side, right? In
Oh,
the end of
okay.
the day, you need to make sure that, you are writing down a controller, right? So your API server is going to be talking via API, right? Whatever API you expose, right? Whatever language you want to
Okay.
use. But people usually use Go since Kubernetes is written in Go, it integrates
Yes.
nicely.
Mhm.
But if you want to use Ansible and Helm, right, Operator SDK supports that pretty nicely, right? So you can write down in Ansible as well. And if you want to use just you want to create a Helm chart, you can do that as well.
Okay. And the other question is like, what would be the fine line where I decide, okay, this can be achieved through YAML or no, this is beyond,
So
like, is there
yeah,
any?
yeah. So see, I mean, it's a great question, right? And there has been a lot of debate on that, right? When you do a CRD or when you do a controller, right? The way I see it is mostly, and the way most of the customers have been doing it, right? If you
Mhm.
want to just store the information, right? If your idea is just to store that information and probably use it at a later point of time in some other application or in some other pod or in some other component, right? You use a CRD. You just use a YML and define a CRD. That's all, right? And you store that information and use it at a later point of time. But
Okay.
if your use case is something where whenever a resource is created, you want to take some action on that, right? You want to, let's say, right, I created an CRD of image store, right? So if you want to make sure that whenever you create a image store CRD, you should be pulling that image on all the nodes, right? In
Mhm.
those cases, it would be a good idea to actually write down a custom controller, right? Or if you have, I
Okay.
mean, one of the very common use cases of writing this down is again legacy applications, right? People who have old systems running and they don't want to re-architecture the whole thing, right? They just want to put the management part in Kubernetes so that they can manage it via Kubernetes, right?
Uh-huh.
That's where this works pretty brilliantly.
Okay.
Is it possible to share the slides? Yes, I guess, Sujay, we can share the slides,
Yeah.
right?
Yep. Yep. Sure.
Yeah, we'll be sharing the slides. Sure.
Do you have somewhere it hosted on
Yeah, I will.
GitHub? Okay. Got it.
I have it in Google Slides. I will just ping you the link, and then you can probably
Okay. Okay.
put it with the
Yeah.
slides.
Sure. And we will be sharing out the link to you soon.
Yep.
Any questions? We are just waiting for another 5 minutes.
Yeah, right. And I guess this is what makes Kubernetes that powerful, right?
Yep.
You don't have to be, you don't need to be a coder or somebody who can understand programming languages deeply. You can just use a simple YML to create an extension of Kubernetes, right? And you can just store your stuff there. Or
Yeah.
you can use something like an operator SDK or even meta controller is that's also pretty easy to implement, right? You
hmm
can just there you can actually create JSON based files, right, and run your own controller. So that's just even brilliant.
Oh,
There
okay.
you don't even need Go, right? So that's pretty interesting.
So one thing I remember, like you
Yeah,
showed in the slide where you were showing with the managed service provider for Kubernetes, you
yeah,
had a block which listed like the service catalogs
yeah,
items.
yep.
So is that a predefined list for all the managed service provider for Kubernetes, or it varies from
Mm,
different?
No, so it could be anything, right? It could be anything that I mean, okay, the use case there is you are running an on-prem cluster, right? And there
hmm
is a pretty nice service that you see that Google is providing, or let's say Amazon is providing, or let's say DigitalOcean is providing, right? And you want to integrate that service with your cluster, right? Now,
Uh-huh.
one of the ways you ask them to do that, right? In that case, you have to provide them access to your cluster, right? So
Yep.
that, or the second option is you do it yourself, right? You develop that capability yourself, you install it in your cluster. Or the third way is you integrate it with your cluster, right? So your cluster
hmm
stays with you, and but you can still use that third party to work with it, and that's where they have the developed this service catalog. Right? So you can actually
Okay.
make use of. those applications or those third-party services.
Mhm. I don't see any questions coming in. So I understand there is this KubeCon going on. Are you attending the KubeCon right now?
Yes,
Uh,
yes, and yeah, I mean, this is pretty interesting. There are a lot of interesting sessions.
okay.
And I guess if anybody is listening to the live stream, but I guess this happens at what, like, it's gonna start in 2.5 hours from now. Like, that's
Uh,
the time zone they have set up. So if you have time, do check it out.
yeah. So whoever is on the stream, we have the KubeCon going on, the Europe edition. Don't know if I have the URL
Okay, the
handy.
code that you share. Okay, sure, I will. Okay, those are written in Go. Yes, Ryan, the codes are, I mean, again, you get an option, right? So when you're using Operator SDK, you can choose, right? You want to use Go, you want to use Ansible, you want to use Helm. As of now, these three are supported, but I believe in future they will support most stuff as well. Thanks, Karan, so that you should come in. Yeah.
So I heard that DigitalOcean is changing the Hacktober Fest this time with some cool ideas about rather than
Yep.
handing over the t-shirts, they are doing something new.
Yeah, I mean, so this is environment friendly posture, right? So there are
Yeah.
two things. One of the thing is with T-shirt itself, we have two modes, right? You can have a light mode and you can have a dark mode, right? So like the websites, right? You want to use a light
Uh,
mode T-shirt, you want a dark mode T-shirt. And another thing is you don't want the T-shirt altogether, right? You want to make it environment friendly. So you can instead we will donate to a charity based on your behalf, and
mhm.
they will plant trees. Right? There are two
Okay.
options that you have. Ryan, which URL you would want? I'm not sure.
Ryan, if you can
Uh,
point out what URL you are asking for, that would be helpful to Piyush.
okay, I can just respond in the chat as well. Yeah, I guess we are up on the
Okay.
time.
Yeah.
Thanks a lot, Sujay, for setting this up.
Yeah. Thanks. Thanks, Piyush. If you're hanging
I guess
around,
yeah, I will
uh,
be here. If you have any
okay.
questions, please ask in the chat. I will respond to it on the chat.
Yeah.
Yeah.
So let me switch to my screen to share screen. So audience, please be patient because this is the first time I'm using this kind of setup.
Yeah.
I am learning while I'm doing it. Okay, so let's go. So I am going to talk about Docker Desktop and some of the cool new features what were introduced recently. Basically, during the DockerCon 2020, we had few new announcements which came out from Docker, which were around Docker Desktop. So let me switch to this one. So do you see my screen, Piyush, being projected? Okay. Yeah. Okay. So I'm going to basically talk about Docker Desktop. So who to so for the people who are new to Docker, Docker Desktop is basically the tool what you would start with to build your containers and push those Docker images to a registry. And basically, it helps you to run containers on your local box. So right now, I am on a Mac, and I am using the latest version of Docker Desktop, which is 2.3.4. And as highlighted, I am on an Edge version, which is basically kind of so Docker Desktop has two basic versions. One is the latest, and the Edge. Edge is where all the new features which Docker is currently developing gets released. So two such features which were recently announced by Docker is they have an integration with two basic cloud providers. One is Azure, and the other is AWS. So you as a developer right now have the options to develop Docker images and run the containers on your local box. And then if you have to move to a cloud service provider, what you would do is that you would push your Docker images to a central repository. In most of us do work with the Docker Hub, and then you would go into the particular service provider, cloud service providers portal, and then use the basic services which is provided by them to deploy your containers. So there's before these features were introduced, there was no way to directly deploy your containers onto a particular service, cloud service provider. So Docker has released two new features, which is called, so those are basically open source projects. One is called Docker ACI integration, which is Azure Container Instances. And the other project is called ECS plugin, which is basically, it helps you to deploy containers on a ECS cluster. So ECS is for Elastic Container Service, which is a service from AWS, while Azure Container Instances is a service provided by Azure. So what I am showing right now, so I don't have any slide deck. What I did is that I have a GitHub project where I'm maintaining all the code base. So we will be basically going through like how to build your containers on your local box and then deploy to mainly, in this demo, we'll be concentrating mainly on Azure. And there are different ways to do it, similarly on Amazon also, AWS also. So if you want to know about the project and the integration, Docker has a well-maintained documentation around it. And I have shared the link in the GitHub repo over here. So let me just paste the GitHub repo for you in the chat. No. So I have Docker installed on my machine, and if I do a Docker version, if you see, it's basically 1903.12, and it says Azure integration 0.110. So that's on the client side. So normally, if you would be running a container, so basically you would start with a Docker file and then build your Docker images and then run your container on your machine. And if you're satisfied, you would push that Docker image onto Docker Hub and then deploy it on your environment where you want that container to be running. So in my case, I have already just developed a Docker image using a Docker file, and then let me just show you how it looks. So by default, when you install the Docker desktop, so there is this concept called Docker context, which is to which Docker engine you are pointing to. So when I did the Docker version on my machine, it says the client, Docker engine, and the server. So basically, it's a client. So client architecture model. So my client, which is my CLI, is talking to this. So this Docker server and Docker engine can be running on a remote machine also. So in my case, if you see, I have various contexts created. If I do a Docker context ls, so if you see, there are 3 listed. So by default, the default is the context which gets shipped with Docker desktop. And if I do a basic Docker images command, it lists all the Docker images what I have on my machine right now. So let's say if I need to run this container, so what I will be doing is that Docker run -p is publishing my port, and then let's see my image name. And if I go to my browser and do localhost, so that's basically a simple web app which is running in a Node.js environment, and I just packaged it up as a container. It's running fine on my local box. So what if I had to do this same container? What if I need to achieve this in a cloud environment? So let's say I need to go and run this on Azure. So what you see on my screen, I am just logged into my Azure portal, and I have this resource group already created. So let me show you how that I could have achieved through the Azure portal, so that it gives you an understanding to compare how easy the Docker tool makes it to deploy the container. So if you go to Azure portal and click on containers, you would see various services provided in the container category. And if you click on container instances, so it gives you a nice UI where you can fill up basic information. So I'm just filling up the basic information. I want this container to be running as close as to me, let's say Southeast Asia. And where is my Docker image? So the Docker images can be some of the predefined images what Azure provides, or you can push it to Azure Container Registry or a Docker Hub. In my case, I have already published the Docker image, which I used on my local box over here onto Docker Hub. So I will use the same image, and it's a Linux-based OS type image. So I'm choosing Linux. So Azure Container Instances gives you basic 2 options to choose your OS type, that is Linux or Windows. And then you can go and choose the OS size, what you want. And in this case, let's hit review and create. So it says validation passed, and let me create it. So that's so what now Azure is doing is that it's pulling up that image from the Docker Hub, and it's doing a deployment for me on the Azure side. So that's how basically the workflow looks like from Azure portal instance. Now, what if I had to do it, staying it within the same environment where I'm developing my Docker image? So that's where the Docker ACI plugin comes in. So if you install by default the Docker desktop, which is basically this one, the Edge channel, you will be having this plugin by default integrated with it. So what you will first have to do is that I'm already logged into my Azure portal through the CLI. So there is this tool provided by Azure, which is called Azure CLI. And I have that installed on my machine. So you can see AZ, or basically you would have done something like AZ login, and it would take you to your account. And it shows all your subscriptions, what you have access to. So I have basically one subscription under my account, and that's what you see on my screen. So to use this same subscription, what I have logged in through my CLI, what I will do is that I would use the command docker login Azure. So it again basically gives access to the Docker CLI, the credentials, what you have configured for Azure CLI thing. So it says login succeeded. Now, what I did is that my Docker client is configured to use my Azure subscription. But to deploy a container or to work with the Docker ACI integration, you need to basically do some configuration. So you need to tell your CLI that I need to talk to Azure cloud service provider. So the way you do it is that you create a context, which is Docker context create ACI. So when you hit Docker context create ACI, this is basically the command, and I'm giving the context a name called test. So it asks you a few set of questions. So to run any Azure resources, you need at least a resource group, because that's where the resource group is basically a logical unit of grouping all your application related resources under a single umbrella, or you can term it as a single folder where you hold all your application related resources. So in my case, so it's basically, if you see, it has went and talked to my AZCLI and fetched my subscription out of it. So it knows I have already one subscription under my account. And then it says under this subscription, you have this resource groups. So which one do you want to choose? So I'm saying that I want to choose the Docker ACI. So if I do a Docker context ls now, you would see a new context which is created under my list, which is test, and of the type ACI, which is Azure Container Instances. So if you need to use that one, I would just switch my context saying that Docker context use test. Now, if I do the command Docker context ls, if you see the star, at first it was pointing to my default context, and now it changed to test. So that means all my commands, what I execute right now, would be pointing to Azure subscription, what I have configured on my account. So let's see what difference it makes. So basically, if you hit Docker now and you see the available commands, the list of commands have changed, because right now your context is speaking to Azure, and it knows that when I am executing against the Docker, the context which is Azure, I have to execute all these set of commands. And if I use, so let me show you the difference, what it makes. So if I switch to default context and do the Docker command, so it's a set of commands available with the default context is different, if you see. So that's basically how the plugin behaves. So it's only a subset of commands which is available when you work with cloud service providers. So I switch my context again to Azure now. So right now, my intention is to run the same container which I developed on my local box on Azure. So the previous command I used to run the container was something like this. So let me put it -d. Port mapping is not. So all we need to do is this. So now what it's doing is that it's talking to my Azure subscription, and it knows that this is kind of a ACI instance which I need to run, and it's creating the container on the Azure side. So if you remember, I had configured my CLI to use the resource group, which was RG Docker ACI. And if I come over here to my terminal, if you see, there is a container which got created by the name called Objective Miracle. So if you go to my Azure subscription and you search, so there is this container instance which got created from my CLI onto Azure. So if I do the same docker ps command as I would do on my local box, so now it's detecting the two container instances which is running under the same resource group. So this is what got created, Objective Miracle. This is what got created through the CLI, and the other container which is running, it was created through the Azure portal. And if I had to go and browse this site, so you see the same application, just by switching my context, I'm able to run it on Azure. So this is live right now. If you hit this endpoint, you can see it on your side also. And let me show you the same IP address. So if I go and open up the overview page for this container instance, and if you see, there is this IP address, which is same I pasted in the chat also. So what the CLI has does is that it talked to my Azure subscription, and it knows that I need to run a Azure container instance. So using the same set of APIs, which is available by Azure CLI, it created the container instance for me using the Docker CLI tool. So within the same workflow, what you were experiencing earlier, so like as a developer, you would develop your images on your box, run it locally. Then when it's turned to run it on a cloud service provider, all you would do is that switch your context and make all the configuration and run the container on Azure or AWS. So this is case for single container instances, but when we are doing a real world development, we would have multiple services. So that's where in a Docker world, we would use Docker Compose. So I can use the same command, docker rm objective Merkle, the command container name, and it would delete the container instances for me. I have never tried this one. Let's see whether if I had not created this, no, it won't allow. So it won't allow you to delete those services which were created through the Azure portal because it doesn't have access to those services. That's what I understand. Let me do a Docker inspect. Container name, container ID. Okay. So let me just go and delete those resources. So the best thing when you're working on a cloud side is that make sure that you go and delete unwanted resources after your use, else you will be seeing the bill being charged to you. So let me first delete those things, make the slate clear. So I have deleted all the single container instances. Now let's switch to something real world. So let's switch to a Docker Compose file. So on my screen right now, I am into a folder where I have already a app which is a Docker Compose based. Let me show you the code, how it looks. So it's basically a Python app which is talking to a Redis instance, and I have already written the Docker file and generated a Docker Compose file for it. So the Docker Compose file looks something similar. I have a front end service and a backend. So backend is using Redis. The front end is a simple Python application, which kind of stores your timestamp when you hit that web page into this Redis container. So if I had to run this app in the same workflow what I've been working with, so Docker Compose would be my tool, and I would do a Docker Compose up. So it gave me an error. The platform targeted with the current context is not supported. Make sure the context in use is target set. So Docker Compose, when you do a Docker Compose up, it always knows how to run those services talking to your local Docker engine. So there is an option to use context as a parameter. So I would say use the default context. So what it has does is that is using my default context to run those containers for me in the Docker Compose file, what I have written. So I have the app running on my local instance. If I do, so if you see, it's the Python-based application. I hit, you're seeing all the logs being streamed onto this onto the CLI output. You can let me kill it, and you can do Docker Compose down. So it will take all the resources down, which is running locally. So that's the normal workflow which we are used to while working on a local box. Now I want this Docker Compose app to be running on Azure side. So it's the same thing. You make sure that your context is pointing to Azure. Right now it's this one. So yes, I'm pointing to my Azure subscription. And then what you would do is that now when you come and hit Docker, you see a new subcommand available under Docker. So they are so Docker is right now integrating the Docker Compose as a subset command, which would be available with this integration. So you don't have to do the normal way of Docker Compose. Rather, you would do Docker Compose and then specify the file name. So by default, it uses Docker compose.yaml as the default definition, but I did made some changes for the Azure container instances. The one change you see is that I have commented out the build part. So Docker Compose by default has a feature that if you specify the build parameter and the image name, when it starts up, if it doesn't find the image available for you, it would build the Docker image for you based on the Docker file you have specified for that service. So in my case, I'm saying that for the front end service, if I was doing this one, use build under this app folder. Use the Docker file what you find under app folder, so which is this one, and tag it as sujaypillai / timestamper. So Docker Compose would be smart enough to know that, okay, I don't find the image on this local box, I need to build it. So it would reference this Docker file and do a build accordingly. That's how it works. But the same feature is right now not integrated with the Docker Compose on Azure or the ECS part also. So what you would do is that once you have done with your build, you would push the image to Docker Hub. And when you execute this Docker Compose file, Azure is going to fetch that image from the Docker Hub for you, or it can be a Azure Container Registry also. So it's basically using this image and it's binding itself to 5000 port. And let me show you how it runs. So I would do Docker Compose -f. I'm specifying specifically this file. And I would say Docker Compose up. So now it's creating all the services related to this Docker Compose under the group demo app. So if you see the YAML definition, I have two services, front end and back end. So it's creating the two containers grouped under this demo app. It would take some time to spin it up. Let me refresh my screen over here. Nothing is coming up yet. So soon you will see images or containers spinning up over here. Okay. So you have the demo app. So demo app is basically the folder name. And in that you have two services, which is front end and back end. So that's how the Docker Compose specification says. So when you deploy the service, it would give the service name identification by the root folder where the Docker Compose file is present, and specific service name which has been defined in the Docker Compose file. So as you see, it got deployed, and if I do a Docker PS, it says you have two containers running. One is the previous one, which let me go and delete that one so that it. So if I do a Docker Compose, okay, so the only available command is down and up. So the basic Docker Compose PS is not still available. So let me go to Azure portal and do a refresh. So I have the demo app deployed. And if I click on containers over here, if you see there are two services, front end and back end, which is basically these two services which got deployed. And if you see there is a third container which is running along with this. So this is basically the DNS provider for this. So if you see when I did Docker PS, this got assigned a public IP and it was mapped with port 5000. So all this networking related thing is handled by this container, what you see, ACI DNS sidecar. So it's kind of the Kubernetes concept where you run a pod along with your application, where you want extra activities to be carried out or some tasks to be executed. So this is basically the DNS provider for this. So if I click on this overview page, if you see, it has got a public IP. And if I go to this URL colon 5000, so basically I have the same um, app which I was running on my local box. I didn't do anything fancy. I just posted it to Docker Hub, and then I changed my context and asked Docker to do all the work for me. So in this case, if you are new to Azure, you basically just need to configure your subscription using the AZ CLI. And once you have done, you keep working on using the same workflow that was uh, known to you while working with the Docker desktop. So you have nothing new to learn, at least to start with Azure. So all the steps what I showed you to deploy manually on Azure is taken care of by the CLI. So that's one of the basic advantage of using the Docker ACI integration. I can do the same stuff if I had to switch my context to, let's say I have my AWS context. So context use. So if I list my context right now, I am in AWS context. So now what I'm doing is that the same set of application which I deployed to Azure, I can do Docker ECS. So there is basically right now, I would say two different set of commands, which is basically for the specific cloud provider. So when I was working with Azure context, I use Docker Compose. Now, when I'm switching my context to AWS, I would be using Docker ECS and then the Compose file. -f Docker Compose, and I would say up. Hope that works fine. So the same set of workflow which I executed against Azure, it's doing on AWS side. So I had already configured my AWS CLI, and all the authentication piece were taken care before this demo. So that's the reason so else you would have to configure the similar way I showed you for Azure also. So first step is you ask your Docker engine to get authenticated with your AWS account. And once that's done, you create a context using Docker context create, and then switch your context to AWS and run the same set of command. So basically the command in this case, it would be Docker context ls, or sorry, Docker compose, Docker ECS compose, and the compose file name. So if I switch to my AWS account, you should see something showing up. So if you see, it got deployed on my side. On my AWS account, I see the demo app, which is having this service. Right now, I have not exposed the service to the public internet, so that's the reason you don't see it. But there's a way to do it. And if you see, the launch type is Fargate. So basically you are using the Fargate mechanism, which is a kind of a serverless mode. So all you are saying to AWS is that I want to run this container, and by default, it chooses the launch type as Fargate. So somewhere on AWS infrastructure, your container is running and you didn't have to set up any VM to make this Docker run for you. So that's how this tool, basically the Docker ACI integration and the Docker ECS plugin, helps you to run your local containers onto the cloud. So it's going to do all the heavy lifting for you. It's creating all the load balancer and the services which needs to be created. So it would take some time. Let me just switch to another. So if I do a Docker context ls, so I see one configured for AWS and AZ Cloud, which is my Azure configuration. So if I do a Docker inspect, Docker context inspect AZ Cloud, so that's where it stores all the metadata related. So I just wanted to show you how that is configured. So under your Docker folder, which is under your home directory, if you go to meta, Docker, sorry, Docker context. So if you see on my screen, I have 3 directories, which is under users, my home directory .docker. That's where your Docker configuration resides. And you would see a context folder. In that, you would see a meta folder where it holds all my Docker context related information. So basically all these 3 context what I created by other than the default one have all the metadata stored under this folder. So that was basically from my side. Let me just share you the 2 projects which are around this. So all these things what I showed on my screen, right now they are under beta release. So things may change while Docker is releasing new features around this. It's being actively developed. So the Docker ACI integration is a work between the Docker team and the Microsoft. So if you see any issues, please feel free to come and open up an issue over here. So let me just share these 2 projects, which would be helpful for you. One is the ACI integration and one is the ACS plugin. So ACI is specifically for Azure, ACS is AWS. And the other thing I need to share with you was the documentation. So if you want to learn more about Azure Container Instances, the app which I had deployed has links to ACI and ECS definitions, specific documentation around it. So you can visit those links. I'm just sharing those links with you. And the other thing, So the other thing which I wanted to share is the documentation around this. So if you come to Docker's documentation, it has a detailed information about how to get started with these two things, what I showed you right now on my screen. So Docker and ACI and Docker and ECS are the two links which would be helpful to you. I'm sharing this in chat. So that's it from my side. Please feel free to ask any questions if you have any. See, while this saves my workload setting up ECS manually. It's not. Yes, Siva, that's true, man. I truly speaking, I have never configured that task definition. What I understand for ECS to work, because my majority of the work is on Azure, and I am a little bit biased with Azure. So uh, all my experience is on Azure, and even on Azure side, using those Azure portal and filling up that information to run basically just a container is not a good thing to do repetitively, at least for the test purpose also. So yes, that's a cool new feature what Docker has released with this desktop version. So, Women, your question about scaling up that container instances, right now, what I know for at least for Azure, that's not supported, that's being worked on. Um, I think that feature is not yet integrated because last time I talked with the Docker team, they said that it's being developed. Right now, there's no option to scale it from the CLI. I understand that. Um, yes. Or let me just try what options are available. Let me just quickly check. I am also not sure how to scale from a single instance container to multiple. So Docker context use AZ cloud Docker Docker login ps Docker run. So I don't see that integration yet. Docker. So let's check that out, how it works. If I had to do it. Docker ps. So Docker compose -f Docker cd meetup. Docker compose -f Docker compose ACI. I would do a scale of front end. Demo app underscore front end equals to 2. No, so that scale which was available in the Docker Compose, is not still available over here. So I don't see an option as of now. But yes, that's a good question. That's the way I would have done it on a local instance if I would have to run that. Let me switch my. So for the people who are new to this, let me show you how I would have done it on a local instance. Docker context ls. Use default and then Docker compose up minus scale. Let me do up the compose up. CD meetup. So Docker compose up. So this option what I mentioned you is over here. So Docker compose scale and the service name is demo app underscore front end equals to so that's basically how you would have done the scale on a local instance. Docker compose scale front end equals to 2 instance. That's not available as of now. Yeah, see, right, that's what you can do it on YAML also, but it's not available on ACI side yet or ECS. So you could do that on local instance, but not on Azure or AWS side. Hope women that answered your question. Yes, CY replicas in the YAML. So that's what I showed you on the command line. I just scaled it up to 2 instances from 1. In this case, it gave me error because already my port 5000 was bound, and so I couldn't reuse it. So it doesn't make sense over here in this service, but I just wanted to show how that scale would happen on a Docker Compose side. Okay, so please feel free to post your questions in the chat. We are watching the chat, be it Kubernetes related or Docker related. We are happy to answer you. If you want all the source code for this demo, I have uploaded it on the GitHub repo under the Docker Penang GitHub account. I think I shared the URL. Yeah. Once again, over here it is. Oh, yes, Piyush. Definitely DigitalOcean would also make a good addition to this one. So, Piyush, just a question to you. Does DigitalOcean has an option to run single instance container? That would be my question to you. like I showed on Azure and AWS, there's an option to run single containers. I never tried DigitalOcean's. Okay, so I don't see any questions coming in. We have another 5 minutes. Any questions around this is welcome. Any general questions related to Docker or Kubernetes is also welcome. Okay, so I don't see any questions coming. Piyush, do you have anything to say or shall I call it now the end? I don't see any questions coming in the chat also. Okay, so as I don't see any questions coming in, so we would like to end it over here. Well, if anyone want to learn more about Docker kits, can join KubeCon later. Yes, UI. So CY, did you get your passes or it's the free one? Because what I understand is the free one has general access to the keynotes only. It doesn't have access to all the sessions going on in the KubeCon. But I think most of the videos will be related at a later part of time, so we can watch it later also. But yeah, if you want, you can join the KubeCon sessions, which are going. There are free sessions from some of the organizers who have the booth conducted. Uh, so basically, you can attend those sessions. Yes, good place to hang around and meet the community. Oh, great, CY. Okay, so thanks everyone for attending the sessions. Thanks, Piyush, for having a session. We would like more sessions from you. If you have free time, please feel free to reach out to us. We would be more happy to have you on our Kubernetes Penang Meetup sessions. Thanks for sharing those grateful lessons around extending Kubernetes. That was great info. And see you next time. So thanks everyone. Thanks for staying back. And see you next time. Okay.
Okay, have a great day. Be safe.